Hi everyone. In today's video, we are diving into something essential. The top 10 generative AI terms you absolutely need to know. Whether you are just getting started with generative AI or already exploring AI technologies, you will come across a lot of key terms. Some might sound familiar while others could be completely new. In this video, I will break down these terms in a clear and simple way so that anyone at any level can understand and follow along. So let's take a look at the key terms we will be covering in this video. LLM, prompt engineering, fine tuning, embedding, RAG, tokens, hallucination, context window, transformers, temperature. Let's start with the first one, LLM. LLM stands for Large Language Model. It's an AI model designed to understand and generate human-like text. These models are trained on massive amount of written content, books, websites, conversations. That's why they called large language models. Some popular examples of LLMs include ChatGPT, Gemini, Llama, and Claude. You can interact with them just like interacting another person. Ask a question and they will respond in natural human-like language. It's like having a super smart assistant. They can help you write, learn, solve problems and more. Next one, prompt engineering, a really important concept. So what is prompt engineering? It is the skill of crafting clear, specific and smart instructions to get the best possible response from an AI model. You can think like this. The better your question or prompt, the better the answer the AI can give you. It's like talking to a super smart assistant, but you have to be clear about what you want. For example, instead of saying write about dogs, you could say write a 2000 word informative paragraph about golden retrievers, focusing on their temperament and how well they fit into family life. So you can see the difference. The second version tells the AI exactly what you are looking for: topic, length and focus. That's good prompt engineering. And this doesn't just apply to text. Prompt engineering is just as important when you are generating AI images, writing code, or even designing conversations. Mastering prompt engineering helps you get the most value out of generative AI. Here is another example. So prompt engineering is the way of communication to the AI to get better results. Now let's talk about a very important term, that is hallucination. In the context of AI, hallucination happens when a model like ChatGPT generates information that sounds correct but it is actually false, inaccurate or completely made up. It is like when someone says something with total confidence but they are actually guessing or making it up. For example, the AI might say that a certain person wrote a book they never actually wrote, or give you a statistics that doesn't exist. It is not trying to lie. It is just doesn't always know what is real or made up, especially when it doesn't have access to verified data. That's why it is important to fact check the AI's output, especially when you are using it for research, professional writing, or making decisions. For example, if you ask who won the Nobel Prize in Physics in 2023, if AI says it was won by Elon Musk for his work on electric cars, this is a hallucination. It sounds believable, but it's not true. It can happen. If the data is missing, unclear, or outdated, the model may guess incorrectly. It has no awareness of what is true or false. If a model generates a wrong content, then we can say that the model is hallucinating. Next on our list is RAG, which stands for Retrieval-Augmented Generation, a powerful method that helps AI give more accurate and up-to-date answers. So how does RAG work? It is a two-step process: retrieval and generation. First, the AI searches for real relevant information from trusted data sources like PDFs, websites, or even vector databases. Generation. Then it uses the retrieved content to generate a response based on your question. In simple terms, instead of relying only on what the model learned during training, RAG allows the AI to look things up on the fly and then answer. just like how you had searched online before replying to a tricky question. This approach makes the AI's answers more reliable, current, and grounded in real data, which help reduce the chances of hallucination. RAG is especially useful in areas like customer support, research, and document based QA, where accuracy really matters. So, if you are building or using AI tools that need to pull in live or trusted content, RAG is a good choice. Let's move on to the next important concept, that is fine tuning. So, what exactly is fine tuning? Fine tuning is the process of taking a pre trained model like general purpose language model and training it a little more using your own domain specific data to make it better at a specific task. Imagine you want to build an AI assistant that answers medical questions. A general LLM might give vague or even inaccurate answers in this case. But if you take that same model and train it further on reliable medical data, it becomes much better at understanding and responding to healthcare queries. That extra training step, where you teach the model using your specialized data, is what we call fine tuning. You can fine tune models to add domain expertise like legal, finance, healthcare, or guide the model to follow custom behavior. In simple terms, you are helping the model learn what you want it to do. So it delivers results that are more accurate, relevant, and tailored to your needs. Fine tuning is a powerful way to make AI truly work for your use cases. Embedding is a technique used to convert words, sentences, or even images into numbers, specifically into something called vectors. These vectors help AI understand and work with information more effectively. Think about it. Humans understand words like cat, dog, or carrot easily. We know their meaning, context, and how they relate to each other. But AI doesn't actually understand words the way we do. It works with numbers. That's where embedding comes in. An embedding model takes a piece of text like words or sentence and turns into a vector, which is just a list of numbers. But these aren't just random numbers, they are structured in a way that captures the meaning and relationship between the words. For example, in vector space, the words king and queen will be close to each other, just like apple and banana, because they are similar in meaning or context. And embeddings are not just for text. You can also embed images, audio, or even code into vector forms so AI can work with them too. So, in short, embeddings act like a bridge between human language and machine understanding, turning complex data into something AI can reason about. Let's move on to the fundamental concept in AI, which is tokens. So, what exactly is a token? In simple terms, a token is a small piece of text. It could be a word, a part of word, or even just a punctuation mark. AI model don't read text the way we do. Instead, they break everything down into these smaller pieces called tokens. You can think of token as the AI's alphabet, the basic building blocks it uses to understand and generate language. For example, the sentence AI is amazing might be broken into tokens like this. Sometimes even a single word like running might be split into smaller tokens like this, depending on the model. These tokens are what the model processes when it reads your input or generate a response. So instead of understanding full sentence at once, the model understands and predicts based on tokens. Companies like OpenAI, Anthropic, Alphabet, and Microsoft charge based on token usage when people access their AI services. Typically, pricing is per thousand tokens. So the more tokens fed into the system, the higher the cost to generate response. Tokenization is the process of breaking down data into individual tokens. This step is crucial in preparing data for AI models, as it allows the models to focus on the essential units of information. Now let's talk about something called context window, a key concept that affects how AI models like ChatGPT understand and respond. So what is context window? The context window is the maximum number of tokens the AI model can see, remember, or consider at one time when generating a response. In simple terms, it's like AI's short-term memory. For example, if a model has a context window of 8,000 tokens, it can process and understand up to 8,000 tokens of text, which includes both your input and the AI's previous replies. But if your conversation or document gets too long and goes over the token limit, the model starts to forget the earlier part of the conversation. It focuses only on the most recent content that fits within the window. That's why you might notice the AI forgetting earlier parts of a chat. It is not broken, it is just working with its memory limit. Newer models are now being developed with much larger context windows like 32K, 100K, or even 1 million tokens, which means they can remember a lot more and provide much more accurate, in-depth response over longer conversations. So in short, the context window determines how much the model can keep in mind while it's working. Let's take another example. You are using a language model with a context window of 10 tokens. It is a very small one, just for illustration. Now let's say you are start conversation. You are asking, tell me a story about a cat who learned to fly. Let's assume this gets tokenized like this. That is 12 token in total. But model's context window is 10 tokens. The model can only see 10 tokens at a time. So it will truncate or drop the first few tokens in this case. So in result, this is the tokens they process. As a result, the model might not understand the full prompt and could produce a confusing or incomplete response. So if the context window is large, then the model can remember more tokens and give response based on the question. Context window will varies depends on the models. Transformer. Transformer is a neural network architecture that was introduced in a 2017 paper by Google researchers called Attention is All You Need. It is now the backbone of most modern language models, including GPT, BERT, Llama, Claude, and many others. The transformer uses attention to decide which words in a sentence are important when understanding a specific word. For example, in this sentence, the dog chased the cat because it was fast. The model can use attention to understand whether it refers to the dog or the cat based on the context. Let's take another example. The cat sat on the mat because it was tired. To understand what it refers to, the model needs to pay attention to words cat, mat, sat. So attention helps the model focus on the most relevant parts of the input. Transformer is a deep learning architecture that uses self-attention mechanism to understand and generate language by processing all input tokens in parallel. Transformers are the core architecture behind today's most powerful AI models. Temperature. So what is temperature in AI? In simple terms, temperature is a parameter that controls how random or creative the AI's response are. When an AI model is generating text, it predicts the next word or token based on probabilities. Temperature adjusts those probabilities to make the output either more creative or more focused. Here is how it works. A low temperature, like zero point 0.2 or zero point 0.3, makes the model more predictable and focused. It will choose the most likely words, which is great for factual or technical responses. A high temperature like zero point 0.8 or 1.0 makes the model more random and creative. It might take more risks or offer unexpected imaginative replies, useful for brainstorming or storytelling. Think of it like turning a creative dial. Lower values equal to safer, more accurate answers. Higher values, bolder, more diverse responses. So depending on your use case, whether you want to precision or creativity, you can adjust the temperature to get the kind of output you are looking for. This is a sample Python code where we can pass the temperature parameter to the model. Like this, we can specify the temperature. So that's it. We just covered 10 essential terms in generative AI. I hope this helped you to build a stronger foundation and made some of these concepts easier to understand. If you found this video helpful, don't forget to subscribe the channel and like the video. Thank you for watching and I will see you in the next video. Bye.